All right, so hello everyone. Welcome on gravity9 Tech Meetup. Today we are going to talk about Angular components and how to make them more flexible with a technique called content projection. But before we jump straight into the technical details, let me briefly introduce myself. I'm Mateusz Kłosiński and I'm lead software engineer in gravity9. I'm working here for about 2.5 years, and my overall experience is around 7 years in programming. I started with .NET, but I was this one person in a team who didn't fear the front-end tasks, so that's how my front-end journey began. And throughout my career, I had the opportunity to work with core components, so the components that are used by other developers. So I needed to gain some knowledge how to write components that are highly reusable and customizable. And today I want to share some of that knowledge with you. So to add some context and maybe explain myself why I picked this topic, we can ask ourselves a question: why bother? Why to care about component structure? Why to create flexible components? In my career, I worked with lots of components. Some of them were written in a really bad way, and some of them were pretty decent. And from all that, I learned that the more effort we put into creating a better component structure and extracting some shared parts of our UI, the better is to work with the whole solution. So if we correctly extract core components and we reuse parts of our UI, then we really minimize the impact of the changes that we do when we need to be, and our UI becomes more consistent because we already have some parts that we created, and we can reuse them when we are creating new pages of our applications. And basically, so the short answer to the question why bother is to just make our life easier when we are writing front-end components. Okay, so today we're going to talk about topics like common component structure that we can come across in our projects. We'll learn about content projection, the content projection types, and we'll also talk about the content projection use cases and benefits. And after this around 30 minutes of theory, we'll jump into the demo and we'll try to use the content projection in practice. So let's first talk about the common component structure approaches that we can come across in projects. I divided them into 4 levels, and each level will describe the component tree, how the components are nested in each other, what are the components' responsibilities, and how the components communicate. It's not a standard of any sort. Those levels just are based on my experience. And of course, each level will have its own upsides and downsides, and the lower level, the worse component structure design is. So first level of component structure design would be just components that probably all who worked on the front end saw. So they are basically huge components, mostly consisting of plain HTML code. The biggest component of this type I have seen had like 8,000 lines of HTML code. They are huge monolithic files. They mix up responsibilities. They duplicate HTML code. So basically, there is no structure and reusability at all. They are really difficult to maintain as they grow because you duplicate lots of code. The responsibilities and the conditions are starting to getting more complex and complex. And it's really hard or even impossible to share some code from them to another components. And in most cases, you just open this component and you copy and paste some parts of codes to other components to share some logic. But they also have some benefits. At the beginning, they might be easier to read to some point of their size. But overall, they are like the lowest level of component structure design that we can have in our solutions. So this might be the example of this component. Of course, it's simplified, but as I mentioned, they are mostly a huge files. But even from this simple example, we can see that there is only used HTML code. We don't use any other components in this component. And we also duplicate some code. As you can see from this example, we can extract at least 2 smaller components from it and share some of that code. At first, let's focus on extracting just one component, and that would be the level 2. So on this level, we start sharing some parts of the UI. We extract common components, but we still don't care about the responsibilities of these components. So we don't care about how the data is fetched, what is the purpose of this component. We're just starting to notice that, oh, I saw this part of UI somewhere else, so maybe let's extract it to some component. And of course, in this case, the reusability is greatly improved because we start to share something. They are much easier to read and maintain, and some of the code duplication is gone. So that's the example of level 2 component from parent component perspective. Compared to the previous example, we extracted the weather column component, and in this example, the crucial part is the key input. And if we go to the TypeScript code, we can see that after we set this key input, we are fetching something from the API. And that's why it's only level 2, because we don't care about how the data is fetched and what is the responsibility of this component. And because of this input and strictly binding this component with the backend, the reusability of this component is still limited because we cannot use it in a different context. So if you want to download the data from different API and use this component, we will have to introduce some conditional logic here. And the more context we have and we want to use this component in different contexts, the more conditions we will have in this component. So instead of building this complex conditional logic here, we can move the dependency of downloading the data to the components above. And that's basically level 3. So on level 3, you are starting to care about the component responsibilities. And you can split them into smart and dumb components. So basically, smart components are the components that are aware of the data source. They know the dependencies, and they care about orchestrating the dumb components. And on the other hand, dumb components take care only of the presentational part of the UI. And they only use the simplest mechanics that we have in Angular. So they will mostly communicate with smart components using, for example, input, outputs, and nothing else. And you can see this example here. So that's the same parent component like we have on level 2. But instead of passing just the key input to the weather column component, we are passing the actual data. So this time, the weather column component can be used in different contexts. For example, we can fetch data from different API, and the only thing that we need to care about now is to match the contract of the weather column component, so we need to pass the correct type of data to it. But it doesn't matter where this data comes from, so it can come from some kind of cache, it can come from NGRX store, or it can come from some service. It doesn't matter to the weather column components. That's why it's now almost fully reusable. And I said almost because we have also level 4. which is the actual topic of this presentation, and this is content projection. And what content projection actually is. It's a pattern that allows content to be passed from parent component to the child component. And you probably use it when you used component libraries like PrimeNG or Angular Material. They often use this kind of technique to allow you to pass some content to their core components. And this technique allows us to remove the strict dependency between the component and content that is rendered by this component. So on the previous example, the weather column component still was bound with the content that it generated. So we couldn't, for example, replace the. It always will present the data. And it was the temperature data for the different cities in different regions, and we couldn't replace it easily. So that's why it still had room to be improved, and we can improve it with content projection. So what content projection types do we have in Angular? The simplest form of content projection in Angular is single slot content projection, and it requires only to use ng content element, and it allows to project only single element to the child component. So it's perfect for simple use cases when you just need to pass some content and don't worry about communication, and with this content projection you can project only a single element to the child component. And from the implementation perspective, it would look like this. So from parent component perspective, we need to put some content between the child component tags. And in this case, we are passing the weather element component to weather column component. And from child component perspective, we need to use ng content element in a place where we want to project the content, render the content from parent component. And in this case, the result will be like this. So ng content, at the moment of creation of the column component, it will be replaced with the content that was passed from parent component. Okay, so from Angular 18, you can also add some default content in case the parent component would not send any content to the child component. You can also render some placeholder for the content. And in previous versions of Angular, it wasn't so obvious and easy to implement. So more advanced form of content projection is multi-slot content projection. It allows you to project multiple elements to the child component, and those elements can be presented in different places of the child component. So it's still using ng content element, but in this case, you will have to use custom attributes as well to mark the slot where you want the content to be projected. Okay, so let's take a look at the implementation. And from parent component perspective, you still can see that weather element component is passed as it was passed before in single slot content projection, but we additionally are also passing the header element, which is marked with this title attribute, which is really important in this case. Because if we take a look at the child component, you can now see that we have two ng content elements, but one of them is like not selecting any attribute from the parent component content, and it would be the default ng content. And we also have this ng content at the top, which is explicitly selecting title attribute. So the result in this case would be to have header rendered at the top of the component because it had the title attribute assigned, and on the bottom we'll just render the default content that was passed to the default ng content. So to summarize, with this content projection, you can basically project content to different places in child component, but still you are limited to only one element. You cannot, for example, assign the title attributes 2 times to 2 different elements in a parent component. You can only assign it to a single element. Okay, and last but not least, we have the most advanced form of content projection available in Angular. It's also the most complex one, but it's giving you the most features that you can use. So it not uses ng content element anymore, and it requires additional elements to be created, for example, directives to mark the content. And but on the other hand, it allows you to project multiple elements, not only to different places, but also to the single place. So that's the most important difference between this and single slot and multi-slot content projection, because you can now pass, like, I don't know, 10 elements and project them exactly in one place, and they will be rendered one under another, or in any way that you configure it to do. This content projection, as the name says, also supports conditional rendering. So you don't have to render the content passed from the parent component, and you decide when to render it or not to render it. In those previous examples, the content will be always rendered, or at least always initialized. So when the child component is created, it will always initialize the content that is passed from parent component. And in this case of conditional content projection, you are in control of the rendering the content passed from parent component. And the result of this control is also supporting lazy loading. So you can load, for example, when you are working with tabs, and the parent component passed you like content for 3 different tabs, then you can decide to render the content only when user clicks on this tab and actually wants to view the content underneath this tab. Okay, and from the implementation perspective, you can see that there are 2 main differences compared to the previous content projection types. And those are that now we are not placing the content directly into the child component. Instead, you need to wrap them in ng templates. And next to this ng template, we have a custom directive that is now marking our ng templates. And from this directive, we'll know where to render the content in the child component. So it's basically similar to the attributes we used in multi-slot content projection, but this time we need to implement it ourselves. And the second big difference is that you can now render ng templates in a for loop, so you can create multiple elements that will be passed to the child component. Okay. This is the example of the directive that we used to marking the content in parent component. You can also mark the ng templates with variables, for example, but in this case you will have to use magic strings in child components, so directives are the better approach, a little bit more clean. And from the child component perspective, we are not using ng content elements anymore. We use now ng containers, but in this case it could be also a div or any other HTML element. What is important here is the ng template outlet directive and rendering which we use to actually render the content passed from the parent component. And here we pass the templates variables that we need to assign in TypeScript code, and I will show them in a while. And here you can also see that the elements that were passed from parent component, the multiple elements, are also rendered in a for loop. So from also child component perspective, but this time in TypeScript code, we need to actually query for the content passed from parent component. And we can do this using the content child or content children decorator, depending if we are looking for one template or multiple. And we can read, as you can see, we are looking for directives because we mark the ng templates with directives, but we can also pass the second argument, which is template ref. And this way we'll basically assign only the template ref to our variables. And we have here the title template and element templates. And in case of the list of templates, we need to use the query list type, which is a built-in type in Angular. Okay, so the one more extra feature of conditional content projection is the ability to have this two-way communication. So on top of having the possibility to pass content from parent component to child component, we can also add some context to the template that we are passing from the parent component to child. And I have used this approach here on this example. That's pretty much the same example that we seen just a few slides before. But in this case, instead of having two for loops to generate the ng templates, and also on the child component side, we have the second for loop to actually render them. This time, we don't have this for loop in the parent component. We just pass the elements as a simple input to the weather column component. And we pass only one template that will be used for all the elements. And the child component is passing as context with this let entry variable, which is each element that were rendered in the for loop will be assigned to this variable. And from the child component perspective, it will look like this. Here still we have the for loop to generate all the elements passed from the parent component. But we also assign this context to the ng template outlet, which is basically the element that we passed from parent component. Okay, so we talked about why use content projection, how to implement it, and now we can briefly summarize the use case and benefits of using content projection. So basically the benefits are that our components become reusable, customizable, and flexible. You can now use them in different contexts with different content. So for example, when you have a requirement to have like 2 pages, they look the same in terms of they have, for example, 3 columns, but they need to render different content inside of them. You can now fulfill this requirement and still reuse the column component and just put different content inside of this component. And with this approach, you won't have to do any conditional logic. So you just reuse the components, put different content in them, and you are good to go. And with this approach also, we have better separation of concerns because each component is responsible for their own work. So for example, now column component is only know that it's generating some content, but it doesn't know the details about the content it is generating. Okay, so the maintainability is also improved because we can now reuse very big chunk of our code and to create new pages, for example. Okay, so the use cases for content projections are, for example, so obvious hints where to use content projection is, for example, when you have to share a common layout between components. So for example, you have this column layout, and you have assigned some styles to it. You have some cross-cutting features like filtering of this column, and you want to share this layout in different pages, so using different contexts, and you can fulfill it with content projection. And anytime you need to create customizable components that will be used in different contexts, that's also a good hint that content projection might be a good use case here, a good technique to use here. Also, anytime you need to write any component that will be used by other developers. So for example, if you're building some table or dropdown or any kind of simple control, and you want it to be customizable, then content projection is a good choice here. And we can look at the examples in Angular Material and PrimeNG. So in PrimeNG, we have this table component. And as you can see, they are using conditional content projection here to put some content into this component. We can create our own headers, and we also create the template for each row in this table, and they will pass us the product as a context. So the same example that we just have, and they implemented it in exact same way. And in Angular Material, for example, when we are using tabs, they also use content projection here, so to get content for each tab from us. And in this case, they are also using conditional content projection, but in this case, they want the tabs to be lazy, to have this feature of lazy loading. So I explained it before. When you click on the tab, the content will load after you clicked and not before. All right, so we can switch to the live demo. After this hard 27 minutes of theory. And basically what we want to do on this demo is that we have existing page that is displaying weather data. It's displaying weather data in 3 columns for 3 different regions, America, Europe, and Asia. And the business came to us and they want us to add a second tab. And instead of temperature data, it will be presenting humidity data, and not for the city, but for the country. So we'll still have 3 regions, still 3 columns, but we want to present different content inside of them. So the current solution is at level 2. And our goal is to implement the feature and also refactor the page, so it's level 4 and is using content projection. Okay. All right, so that's the current state of the app. As you can see, we have 3 columns, like I mentioned, for each region. We have this ability to filter the column, and it's displaying the data for each city in this region, and it's only displaying the temperature at this moment. And our goal is to implement this second tab about humidity. So let's jump right into the code. I hope it's visible. Can you read in the last rows? It's okay? Okay. This app is in the root component. We have just the router outlet. And in the routes, we can see that we have this temperature route. And we'll implement the second one, which will be humidity. And let's take a look how the temperature is implemented right now. So in temperature, we are using 3 times the weather column component, and we are passing the region to this component. So it's a hint that we are not following the level 3 standard, so we don't have the parent components, they are not smart. Instead, this weather column component is fetching the data each time we assign this region input. So at this time, we are not able to reuse this component, and we want to. So let's begin with creating the humidity component, which will be the similar one to this temperature component. Okay, let me just rename the styles to be SCSS instead. And let's make this component standalone. Okay, we want to use the weather column component here as well, so we don't duplicate the code. So let's go to the temperature component and let's paste it here. And we also need to actually use this temperature component, so we need to enable the navbar. And we also need to add a route to this humidity component. Okay, so, oh, it's not displaying still. Let's see what the error is. Oh, okay, we don't have the weather API here as a provider. Okay, now it should work. Okay, just give me a second. I will take a look at the already refactored humidity component because I'm not sure what happened. Oh, okay. Sorry about that. I have the wrong import here. Okay, now it should be the same. Sorry about that. I'm really sorry. So we have now the temperature component and humidity component, and they are basically displaying the same set of data. We want to display different data in humidity components, so we need to take a look now at the weather column component. And the first thing that we need to do is to remove this dependency from the API. So we need to move this API call higher in the component structure. And in this case, we'll implement this in temperature component first. So we need to fetch data in temperature component, and I will take this from already implemented because I lost some time on this bug that I had. So let's fetch the data in parent component. Let's inject the weather API here. And now we'll fetch the data for each region from the temperature component. So first we need to refactor the temperature component, and then we'll take care of the implementation of humidity component. And we also need to have some models. Okay. So we are now fetching the data in parent component, and we need to change the weather element component to not be dependent on the data provided in this input. So we'll have input to provide a region. And we'll have another input to provide the data. And we'll get rid of this set input. Okay. And now we can also get rid of this observable. And we can remove the weather API from this weather column. And now in the parent temperature component, we'll pass the data that we fetched to this weather column component. And instead of setting the region, so let's refactor this a little bit as well. This will be data. Okay, we can get rid of this previous implementation. And let's comment this out in humidity component for a bit, because it will generate some errors probably. And the for loop must have a track expression. Okay. Okay, well, we need to also change the weather column component here. So instead of having this async pipe, we are now receiving the data and we are not fetching it from the backend anymore. Okay, so the temperature component works now after this series of fails. So basically now, from temperature component perspective, we can see that we are not fetching the data from the weather column component anymore. We are currently passing it from the parent component, so we are currently at level 3. We have this temperature component as a smart one currently. It's taking care of fetching the data from the API and passing it to the dump component, which weather column component became. But still, even if we implement it in humidity component right now, we won't be able to pass the humidity data actually, because it's still strictly bound to the temperature data that it's only able to render now. As you can see here, it can only still render this temperature data. So the next thing we need to do is to extract the component from this HTML code, and then we'll introduce content projection in this component, and it will allow us to implement the humidity component. So let's create a new component now. And let's call it column element component. It will be SAS as well. It's going to be standalone. And now let's extract the content from the column element component, weather column component. Okay. Okay, and we also need to extract the styles for this component. Which is the beginning. Okay, here. To the weather column element component. Okay, sorry. Okay. Oh, is there something else used here? It will probably also require common module because it's using number pipe. Something else? No. Okay. So we are now ready to replace the plain HTML code here with our new component for weather elements data. Let's import it here. And let's replace this HTML code. Oh no, that wasn't weather element. It was. And let's see if it works. This time it works. So now what we want to do is to introduce content projection. We already have this part extracted, and we want to remove this dependency in column component from this element displaying temperature data. So let's now implement the actual content projection, and for that we'll need directive, which let me copy so I don't waste time to implement it. Where it is? Column content directive. Okay, so as you saw in the presentation, it's just a directive with no content that will be used to mark the place that we want the content to be projected. Okay, and in weather column component we want to query for this directive. And we'll read template ref assigned to this directive. And we need to assign it to some field. Let's say, call it okay, and now the child component will look into the content provided by parent component, and if it will be provided, it will be assigned to this. If the template will be provided, it will be assigned to this variable. So let's now refactor the HTML code, and instead of strictly rendering the weather elements, column elements, we'd like now to render the content projected from the parent. So we'll use ng container. And it's called column content. And we will use the more advanced approach with context, so we'll be passing context back to the parent component. And it will be the city. Okay. And I have a typo here. Okay. Looks good so far. Let's now go to the temperature component, the parent one, and let's make the column element component its dependency now. sorry, we need to, of course, wrap it in ng template. And we also need to have this column content directive imported here. Okay, let's take a look. Looks good so far. So as you can see now, we are at level 4. So our temperature component became smart one, and it's also responsible of orchestrating the dump components, and it's also providing the content for this column component. So now we can use this column component to display different data from different contexts, and in this case we want to pass, sometimes we want to pass and display temperature data, and in other cases we want to display humidity data. And on the other hand, the weather column component doesn't know anything about the content that is going to render, but it's because it previously received the city weather, it was still bound to the type of this city weather. Let's for now make it unknown. You can also make this component generic, but I don't want to fall into another trap and waste 10 minutes to debug it. Okay, so let's now implement the humidity component. We can now do it. And let's get rid of this code. And let's use it for now. Of course, we'll display a different component here. And we also need more imports from this one. Okay. And I will help myself a little bit to fetch the data and transform it to the correct format. So we will count the average humidity for each city that was displayed on the first screen, and we'll display it on the second one. Okay. We still want to fetch this data like in the okay. And there's one additional element that will allow us to actually calculate the humidity, which is a pipe dedicated one, and the model that will display the humidity, we also need it, and the pipe that I already implemented, which will basically take the each city data, it will aggregate it and count the average humidity and return this to us. So let me just take it. And in this humidity component, we'll also need this pipe. Okay. But there is one more thing that is still not implemented here. So this column element component is still displaying only temperature data. So let's quickly replace it. So we'll have in temperature component, we'll add new component. Okay. Why I can't rename it? Okay. Why I cannot rename it? Okay, so maybe let's do another approach. There's two here. Okay. So basically what we want to do is this element to display different data based on the context as well. So we'll have this up weather element and we'll pass the temperature template for the temperature. And for the humidity, we'll pass the humidity. Okay, so we'll have this column. Okay. And in this column, element component, we need to introduce the simple content projection type, which will be just ng content. So this column element component will be now able to display whatever content we'll send to it. And instead of city, it will just display title. Okay. Okay, and we'll do the same for the humidity component, and to save some time, I will just copy it. Okay. The closing tag. I will get back to it. Just let me do this one. And okay. So in temperature component will not display the column element anymore, but the temperature element. And we need to import it. Oh, okay. Let's take a look at this. Oh, okay, this column filter is probably also working on. Yeah, okay. So basically what we did now is we introduce content projection also for the column element component, but the simpler one, not the conditional one, to allow us to encapsulate some of the styles related to the element. So for example, this how it looks. And we created smaller components dedicated to to displaying temperature, which are just passing content to this column element component to display the correct temperature and the country code. And for the humidity component, we also created dedicated humidity element, which is also using this column element with the same styles, but in this case we are passing the humidity data. So let's take a look if it works. And it doesn't. Okay, that's because we didn't change the template of this humidity component. So let me take a look. And it should look like this. Okay, so in this case, we are using this humidity element component. We are using a dedicated pipe for each region, so we transform the data about the cities to the data about the average humidity in countries using this dedicated pipe. And we are passing this data to the humidity element component, and we are doing it all from the parent component perspective. So let's take a look now. Up weather column. Data. Okay, because we named it differently. Up. And it probably have a different name. Yeah, city weather. Okay. We didn't change the name of this input. Okay, and we also need to import this. Okay, and now, as you can see, we finally reached the expected state of this application. So we have both temperature, displaying temperature for each city in given region, and we also have this humidity also displayed for each region, but in this case we are calculating the average humidity for each country. And basically what is the best part of it, that we don't have a single if in this solution, and it's fully reusable, so we can do another tab displaying this data in columns, and we can display anything what we want. We can reuse both the column element components, but we can display any sort of data in this column components. Now we don't have to display this column element. We can display just single element. We can display multiple elements, just whatever we want, and we will have this always consistent column layout that we initially created. So each time there will be requirement to change something in a column, we'll just change it in one place. And that's basically all that I wanted to share with you. Sorry about the issues with code. I didn't expect that it will go so wrong on live, but fortunately I had some code snippets and I already did this refactoring, so I could finish it in relatively good time, I think, but we are past time, so sorry about that. And in case you have any questions, then feel free to ask them. Go on.
How the work of change detection will be affected with each level. So on the first level, we had everything rendered in one component. Then we changed it to passing already generated components, and then we changed it to passing like templates and generating components inside.
So basically in single slot and multi-slot content projection, the content is always initialized at the moment when the child component is created. So it won't change even if we do some modification in parent component, it won't be reflected in child component. So it's basically not related to change detection at all. And in case of conditional content projection, each time we change the templates, so we can pass more templates or remove some templates. You saw that we had for loop even around the templates, so it will be reflected in child components. So each time we will change it, it will trigger change detection as well. And it will be read by this content child and content children decorators. So that's why in terms of content children, we have to use query list type, because it will listen to changes in the content passed from parent, and each time it will change, it will also be reflected in this variable. Okay, any other questions? Okay, then thank you for your attention.